Welcome back to my channel. In my previous video, take a look at the physics practical on mechanics. Before we proceed for today's video, which is on what optics, please I would like you to subscribe to my YouTube channel and please click on the notification bell to receive notification on my new videos. Now let's get started. Today we are going to be looking at the physics practical of optics. Now we are given a diagram like this. Now, how do we perform the experiments? Following the procedure given to us. Now, from this point, we are given that arrange the illuminated objects, the converging lens, and the screen as shown. Now, from this place here, we are given a screen. This is the illuminated object given to us. We are given the lens and the lens holder, and also we have a screen that is here. Now, we have the ruler that is used to measure the distance between the distance moved by the object. Now, the first thing I need to do in this experiment is to keep the distance, take the object, place it at the 0 centimeter mark of the rule, and also the screen at 100 centimeter mark of the rule. Now, the screen can be moved from one point to another. Now, if you follow the procedure given to us, you'll be able to perform the experiment. Now, from here, we are given that place the converging lens at a distance u of 30 centimeter from the objects. Now, this is my illuminated objects. This is my converging lens. If I place this converging lens at a distance of 30 centimeter, if you check on this, please note, if you have to perform this experiment, try to make sure that the graduated scale of the rule is facing upward. Now, this is it here. Now, I have this, placing it at 30 centimeter mark. If I place this at exactly 30 centimeter mark, we can find the center point of this by indicating like this. If I have this as the center point of the rule, now placing this like this on the rule at 30 centimeter mark. Now I'll be having this exactly 30 centimeter in this place here. This one is placed at 0 centimeter. It is placed at 0 centimeter from the exactly at 0 centimeter on this. While this is placed initially at 100 centimeter mark. Now we can easily calculate. Now, if I place this at 30 centimeter mark, which is fixed, then you can from the object and adjust the position of the screen until a sharp image of the object is seen. Now, what is the object in this case here? We have illuminated object. The object in this place is my wire. This wire that is there, this is serving as an object. Now, I want to find the image of this object in this screen here. Now, let me place it. Now, so if you place this at the 30 centimeter mark of the on this place, in checking it on the rule, this 30 centimeter mark, then we'll move the screen in such that the sharp image of the object will be shown on the screen. Look at, starting from 100, if I move the screen, you notice there is a change whereby at this point I have the sharp S image at point 88. At the mark 88, the image of the object is very, very sharp, whereby the distance from here to here is the distance of the image. That means the image distance, while the distance from here to 10 centimeter is the object distance. Now, my image distance V in this case is given as, this is 30. We have a sharp image at 88. My image distance should be 88 minus 30. We are going to get value for that, which is going to give rise to 58 centimeter. That is for when the object distance is 30 centimeter. Also, we are going to measure the height of the image. The height of the image is given to us. If you take a look at this, from here, I have the image to be here. This is the height of the image. I have an image height of 4 centimeter. The image height HI equals 4 centimeter. Now, the object height can be measured initially. The object height is always constant, which is the distance from year to year, and is measured at 2.5. Sorry, the object height is measured as 2 centimeter. The object height H0 is equal to 2 centimeter. Now, we are going to calculate the new, when the distance is now placed at 35 centimeter, what will be our new image distance? Now, placing this at 35 centimeter mark, then try to move the object starting the screen starting from 100. You notice that there is a change in the image at 81 centimeter. There is a, let's move. We have exactly sharpest image at 80.5 centimeter. Now, the image of the object is at 80.5 centimeter mark. Now, the distance from year to year, that is the object, there is the image distance, which is, if I have this as my V1, my V2 should be equal to 80.5 minus 80.5 centimeter minus 35. We are going to find the answer to that. Why the image height should be given to us as this. Take a measurement from here. This is the height of the image, which is 2.5 centimeter. The height of the image HI is, sorry, let's take a measurement very well. I have this, and this should be 2 points. Sorry, I have 2.5 centimeter. Yeah. So my image height HI equals 2.5 centimeter, where the object height is constant as 2 centimeter. Now we can also change the distance to 40 centimeter. When my distance is 40 centimeter, I'll move this my screen, my convex lens to 40 centimeter mark. At 40 centimeter mark, this is my 40 centimeter mark. We'll find the image where we have the what sharpest image by moving it backward, changing it. I have my sharpest image at this point, which is 79 centimeter. I have the height of the image to be equals to 2.0 centimeter. The height of the image, when V2 equals 79 minus 40 centimeter, we're going to look for that. Now, the height of the image by then is equal to 2 centimeter. Now, again, finding the distance, when the distance of the object is 45 centimeter, placing this at exactly 45 centimeter mark, this 45 centimeter mark, we'll find the distance, this 45 centimeter mark. Now, what will be the image distance? Take again your screen, move it until you're going to get the sharpest image. Sorry, this is a sharp image of the object. The sharp image of the object is located here at 45 centimeter mark. I have my image here. I'll be having this. That is 80.1 centimeter. That means from here, sorry, there must be something wrong in this place, in this my measurements here. At 40 centimeter mark, exactly at 40 centimeter mark, here, the image of the object, where I have the sharpest image of the object, it is located at exactly 78.5. 78.5. 78.5 centimeter. That should be an error. Now, when the object is now placed at 45 centimeter mark, the object's sharpest image is formed at exactly 79. That is, my V2 equals 79 minus 45. 79 minus 45, whereby I will find the value to that later. The height of the image that is formed is given to us as this. From here, that is 1.5 centimeter. The height of the image, HI, which is the height of the image, is given as 1.5 centimeter. Now let's take a look at when the distance is now 50 centimeter mark. At 50 centimeter mark, remove this, I'll be having this. At exactly 50 centimeter mark, when the mark is at 50 centimeter, I have this. Moving this, I have a sharp image of the object at exactly 82.5 centimeter. The sharp image of the object is at exactly 82.5 centimeter, which my V equals 82.5 centimeter minus 50 centimeter. This is my image, whereby the height of the image formed is given to us as 1.3 centimeter. The height of the image that is formed at that point, HI, equals 1.3 centimeter. Now, we are done with this, my experiments in this case. Now, from here, I can easily calculate for here my V2, my V, when my V here should be 80.5 centimeter, 80.5 centimeter minus 35 to give rise to 45.5 centimeter, 0.5 centimeter. Here, 78.5 minus 40 to give us 38.5 centimeter, 38.5 centimeter. While 79 minus 45 should give 34.0 centimeter. Why? My last one is 82.5 minus 50 will be giving me 32.5 centimeter. 32.5 centimeter. Now, from what I've been able to solve in this place here, we'll be able to calculate for my image distance at each position of the object. Now, I can easily tabulate it in this case here. When the distance is 30 centimeter, when the object distance is 30 centimeter, the image distance is 58 centimeter, which is 58.00 centimeter. When the object distance is 35 centimeter, I have my image distance at that moment to be 45 centimeter, 45.50 centimeter. When my object distance is 40 centimeter, I have my image to be equal to 38.5 centimeter, 38.50 centimeter. And when we have V2, when we have 45, my V equals 34.00 centimeter. Now, when the object distance is 50, my image is equal to 32.50 centimeter. Now, from here, from this point here, I have 32.50 centimeter. Now, my hi, which is the object's distance, the object height, my hi, which is my image height, is changing. Don't forget I said the object height is always constant. It seems that this is not varying. I can remove here by removing the object's distance, placing only the image. Yeah, I can have that here should be hi over h naught. It does not have any units. Why? Because this is in centimeter. Why is it using what? Centimeter. So the total unit of this is equal to 1. No unit. Now, my object distance h naught, object distance h naught equals to, as calculated from here, is equal to 2 centimeter, which is constant. The only thing that varies is the image distance. Don't forget that when you are moving an object closer to the screen, when an object is moving away from the screen, the image tends to reduce. The image of the object tends to reduce. Are we together? But if the object is moving closer to the screen, the image of the object tends to increase in size, and the image is always real, with the exception that when the object is placed in between the focus of the lens and when the object is placed in between the focus and the pole of the lens, that's when the image that will be formed will become virtual. That is by a convex lens. Now from here, my hi can be calculated. Hi equals 4 centimeter. We'll measure from the height of the image initially is 4 centimeter. So here should be 4.00. Now, when the distance is 35, the height of the image is 2.5 centimeter. I have here to be equal to 2.50. While my distance hi is 2 centimeter, that is 2.00. While my distance in this case here is 1.5 centimeter, that is 1.50. And then when it is at 50, I have 1.30 centimeter. Now from here, I can easily calculate for my the ratio of hi to h naught. Now, since hi over h naught is this divided by your object height. Now, this ratio, we call it the linear magnification, or the linear magnification of the lens. Now, the linear magnification of the lens can be represented as m. Now, from here, I can find image height over object height should give rise to what? 4 divided by 2, that should what? Have 2.00. Yeah, 2.5 divided by 2, that should give rise to 0.5 divided by 2. I'll be having 1.25. Then I have 1.00. I have here to be equals to 5 divided by 2. I'll be having 0.75. And the last one, 1.3 dividing 2 to give 0.65. Now, this is my reading. This is the reading that you are going to get from your experiments. This is the reading you are going to get from our experiments. Now, we have to find, repeat the reading. We've done all this. Say, calculate the slope of your, plot a graph of hi over h naught on the vertical axis and v on the horizontal axis. Calculate the slope of your graph. Now, in my next video, we are going to look at how to plot the graph of optics. That means the graph given to us in this place. How do we plot this graph? And also, how do we calculate for our slope? And the likely precaution that will be given to us, that will be asked in this question here. Thanks for watching my video. Please subscribe to my YouTube channel for more videos. And please try to click on the notification bell to receive the notification of my new video. Thanks.